guys, let's finish up graphing exponentials today, and then next week we actually solve exponential functions, okay? So to remind you, an exponential function has a base and a power, and I don't know if I said this to you guys yesterday, but the power will always have a variable in it. It's not like x to the second. It's going to be like 4 to the x or something like that. So that was our parent function, remember? And then we learned how to graph it when we added in the h and the k. Now I told you about a yesterday, but we didn't have any that had a in it. So today we're going to have a, which is a vertical stretch or shrink of your graph. So if you want to write this part again, you can. The h is your left or right movement. If it's positive, you go to the left. If it's negative, you go to the right. So remember, that's your horizontal movement. It's always opposite of the sign. K is your up and down. Positive goes up. Negative goes down. This has been the same notes we've had with so many different graphs. They just have different shapes. H and K do the same thing to every graph. A does the same thing to every graph. In pre-calc right now, I'm teaching sinusoidal functions, which are waves and curves, or curvy graphs, and they have H and K there as well. So I'm like, you guys have heard this your whole life practically, you know. So you see it over and over again. So A, though, is the only new part today. It's a vertical, that's such an important word, stretch or shrink. Yes, J. See? Okay. So if something affects your graph vertically, and a graph is made up of a whole bunch of ordered pairs, right? A graph is just x, y, x, y, x, y, x, y. Evan, why don't you fake it just for me a little bit? X, y, x, y, x, a whole bunch of points is what this graph is made of. If there's a number after the equal sign, and we say it's going to affect the graph vertically, what part of the ordered pair is going to change? Is it going to be the x or the y value? Which part of an ordered pair, x and y, which one is your left and right? One of those is left and right. One of them is up and down. Which one is your up and down? Y, right? This one takes your graph left or right. This one is up or down. So 2 affects the y value. So just like we just did these with on the last test with radical functions, we start with the parent function. So let's do that again. We're just going to use those same 5 values every time. -2, -1, 0, 1, 2. And watch. We only plug in to, I'm sorry, let me change that. I guess we're going to do the whole thing. Sorry. Wait. I'm right. We're going to plug right into there. So I'm going to do y equals 2 times 1/2 to the x. And I'm going to get a y value to graph with that, okay? So anytime there's an a, like yesterday we wouldn't have had an a value, so we didn't even write it like this, it was just quick, we did it in our calculator. This is going to be a little bit more work. Now listen, you have to put it in your calculator correctly. Start with the 1/2 and do 0.5, it's faster. 0.5 to the power of -2, and then times 2. And that will get you 8. So, we're basically just doing, I don't like this. I don't like how I'm teaching this. I need to change a little bit. Let me just fix something really quick. If I just put in the y value, let's just do the y values. Let me stick to what I was saying. So just for the parent function, I always will get, I don't like any of this. Yeah, let's just plug it in. So we don't have to do, I'm debating which way I should teach this. And I've taught it both ways, so I'm just trying to think of what will be the easiest. Let's just, instead of, if you want to write something in here, you can, but you don't really need to, okay? Or we could have just put our number right here. When we get y when we do this math. So let's make our XY chart like that. Sorry. I kind of changed gears right in the middle. Let's just keep going through it. So it's going to be 0.5 to the power of -1. Hit enter. Don't even write it down. We're not done. Then times 2. And we'll get our next y value. And just keep going. 0.5 to the 0 power times 2. And we'll get 2 the whole way through. We have to do all in the calculator though, because when there's an a value there, you can't just flip the numbers like we did yesterday. So 0.5 to the power of 1 times 2 gives you 1. And no, it shouldn't. 0.5 to the power of 1 times 2. I must have done this wrong last time. Okay, and then 0.5 to the power of 2 times 2 is a half. Those are what we're going to use as our starting points. So these are the ones we're going to use x's to graph. And then, guys, let's just talk about it real quick. What are we going to do to all those points? What is this minus 2 going to do to all the points? What direction, minus 2, up in the air, is that going to take all of our points? Right to. So we're going to graph these as x's, and then we're going to go right to with all of them, okay? And again, remind me when we're done with the notes, we have one more to do. If you want graph paper, I will give you some. Okay, so starting with -2, 8, -1, 4, 0, 2, 1, 1, and 2, 1 half. So those are these points. That gets us 2 times 1 half to the x. Now, we're going to take all those points and go right to. Like, just count. 1, 2, 1, 2, and so on. Much easier to do with graph paper. Don't touch your asymptote or anybody else's. It's rude. Where's my asymptote on this graph? And remember, asymptotes are lines. So you have to say that it's a line when you name it. The horizontal asymptote, why horizontal? Because it's a horizontal line. And those always start with y. Notice it says hey. So horizontal asymptote is y equals 0. What changes the asymptote? K. You get your asymptote. Such a fun word, right? Kiss my asymptote. I know. You almost think, oh, we were cussing a lot yesterday, Robbie, Sam. Let me think of the joke. Holy shit, look at the asymptotes on that mother function. I have to really think about it before I say it. Okay, so we just shifted. We shifted our parent function to the right. And look at the asymptote. Okay, let's do one more, and I won't mess up on this one. Here it's putting it all together. We got A, we got H, we got K. We got a stretch by 3, left 1, down 3, with a base of 1 half. Okay? We start with the XY chart. X's are always the same. Could you use more? Of course you could. But we need those. And we are going to plug in just to the x. Don't go past x. So we're going to plug right into 3 times 1 half to the x only. And that's going to give us our new y values. Okay? So you pick up your calculator. We got 0.5 again. So we're doing 0.5 to the power of -2 times 3. And we're going to go through the whole XY chart. So why don't you guys take a second and do that? Fill in your chart. You don't need to just copy mine. Pick up your calculator. Do this. You actually can type it in left to right, too. Just realize that. 3 times 0.5 to the 0 power also gives you the right answer. Seeing people pick up their calculators and try this is making my heart happy, and I'm paying attention to who's doing what I'm asking them to do. So when you have a question, I'll say, I'm sure you have a question because you didn't pay attention. When you get to the decimals, you can leave them as decimals or write them as fractions. You can hit math, enter there if you want to. Doesn't matter, okay? And you should get 0.75 here. All right, so these are our starting points. We start there. Then that +1 takes all our points which way? +1. What does it do, guys? Left 1. Good, JT, you're getting it. So JT, what about this one? What is that going to do?
Down.
Good. So start with these. Don't connect them. So -2, I'm going to draw it to scale, or no, I'm not. -212. Remember, if you don't want to use a whole bunch of graph paper, just name it for me. So if I was grading a test or a quiz, I would know you knew that's not 12, but you labeled it for me. All right, -1/6. All right, so those are my x's, not connecting them. Now we move all of those points, left 1, down 3. So just all in one motion. Left 1, down 3. Left 1, down 3. We are going to talk about that. Our graph looks like this. Now it looks like it stops there, but we know we call it the behavior of the graph. It makes like a curve, right? So you can just, you could make more points if you wanted to make it perfect, but you don't have to. You can kind of assume it's, whoops. Gosh, I told you guys I'm not on my game today because of my back. Tell me what I did wrong. Who was it? Over here, Shane. What did I do wrong? Asymptote is -3. What did I do? I went below it. But I have white out. I don't know about you guys. You guys are hopefully using pencils. Harold, I promise I know how to do math. Okay. One of the things I told you guys yesterday is put the asymptote in, and I should have talked about that first, because you won't accidentally cross it. Once I have it there, it's a guide to tell me, okay, I'm going to be curving here. And you know your graph gets really, really close to your asymptote, but doesn't touch it. So I shouldn't have gone below it, because you can't touch your asymptote. And HA then would be Y equals, remember you always get it from your K. So if there's no K value, it's 0, right? Thank you, Shane. That was helpful. Okay? Now I'm going to give you the 4 problems, and I'm going to do the first one with you. So I'm going to put them up. I'm going to come around and offer some graph paper to you. Okay? So I'm going to do number 20. Just call it 27, 28 times. Or call it 1, 2, 3, 4. I think I pulled them out of a book that you guys don't have. But anyway, these are the 4 problems. I think I simplified them. And I'm going to do 27 with you, but those are the other 3 problems. Graph paper. So let's start with 27, and then I'll put the 3 problems back up again. If you didn't read them, of course, I write them. I'm sure you didn't have time to write them. I get that. But let's do number 1 or do you guys want to just write them because you're in the mood? Are you in the mood to write them? What do you want to do? What's the order of operations? Okay, I'll just do 27. All right, here's your first problem. This is C19. And you can just call it like 7.1 day 2. Okay. So our first problem of 4, and I'm going to do this one with you, has a really yucky B value. That's why I want to do it with you. Because I don't want to always give you the nice, easy numbers, okay? Because that's not realistic. You're not always going to have nice, easy, simple numbers, okay? So let's make our little XY chart to plug in up to there, right? Only up to the X. Remember, f of x is y. We should know what our x values are, right? -2, -1, 0, 1, 2. And then we pick up our calculator. So I'm going to type in -4, and you can hit times, or you can just put it in parentheses. 3 divided by 5, close my parentheses, to the power of -2. Make sure you can plug these in. Don't copy my answers. Now, I can either write that as a decimal, totally fine, or I can write it as a fraction. I actually like the decimal version better, right? -11.1 is fine. Because really, what's the difference between a -11.1 and -11.11 or 111? There's no difference really on the graph, okay? So go ahead and start working on these. I mean, those are terrible numbers. They're awful. But remember, it's a curve. We just do the best we can. Okay, so we're going to make these points our x's, right? And then the +4 will move all our points left 4, and then up 3. What's our HA going to be? Y equals what? 3. Right? You always get your HA from K. So many variables. Okay, so I'm going to go to the left 2, down 11.1. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If you don't want to use that much graph paper, you don't have to. Just label it for me. .7 is between 6 and 7, right? Somewhere in between. So you can kind of see that curve happening there, but that's not our final graph. We have to move all of these points left 4, up 3. Let's not follow my mistake last time. This is the moment you want to put your asymptote in. It helps guide you with your graph because you know you cannot cross this line. Okay? That's the line there. So we're going to go left 4, up 3. And it's hard to do with decimals, okay? It doesn't have to be perfect. And by putting that asymptote in there, I know where my curve is really going to have to take a good, I'm not going to keep going down anymore. I'm going to keep going to the right. It looks like this because it has a flip in it, flipped over the x-axis. Okay? So you have 3 to do on your own. Guys, you know I give you the key with the work and everything to almost everything like today. Don't just copy it. That doesn't get you learning what to do for a test. Okay? I know you need the other problems. Let's pick them up. I'll put all 3 up in a second. I just want to give people a chance to finish 27. Good. You have 27 done, Jess? So 28 and 29. Oh, for heaven's sake. I'm going to put it on Canvas too. Let me put it on Canvas real quick. So, by the way, I did it a little bit differently last year, like I was saying to you. Here's my X. You can ignore this. Okay, ignore the middle column. You're putting everything in a calculator and going right to this number. Okay, I did it in a couple different steps last year. So when you put this in a calculator, you should get this Y column. Okay, let me cross out those columns. X minus 3, yes. You write so big, you can't see the whole thing. Gosh. That's why I'm trying to put it on Canvas. So. On your phones, since you love the game. Okay. I'll be right with you. I'm coming, JT. Yes, so 0.75 is the same as. Yeah, so that's. Yeah. You can leave it as a decimal or fraction, it doesn't matter.
I got it now.
You got it? Okay. Almost on Canvas, guys. I'm almost there.